When I saw let's pray. Father, thank you for today. We have a short day, and so we want to get a lot done. Pray we can do it well, do it efficiently, and do it for your glory. Praise you for all of these kids. Watch over them, keep them safe, because there's a lot going on this weekend. Praise you for the time that you've given us, even though it seems short. Pray that we can use it and use it well. Praise you for Christ and the cross. And just, Lord, that you are found strong in our weakness. In Jesus' name, amen. Here we go. We need to find our, what's capital F? Antiderivative. How? Using our rules. Yeah, duh. Right? Forever quiz probably coming. Heads up next Wednesday. So, antiderivative of 2x's. 2x squared over 2, which is x squared. Focus. Sit. Notes. Open. Go. Come on. Give me one day. Derivative of secant tangent. No, not derivative. Antiderivative. I'm going, thank you. 0 to pi over, good, but I need to make sure I enunciate for those that might not. How do I proceed?
So you would b minus a. That's a b minus. That's a minus.
Focus. Guys, for any people who have been doing this yet, the easiest place to make mistakes is the solving part, like the negatives and the positives and the adding and the subtracting. So be careful. F of b, I'm keeping it in parentheses, minus f of a, 0 squared minus secant of 0. Simplify. Simplify. So pi over 3 squared is pi squared over 9. Secant of pi over 3 is 1 over cosine of pi over 3. Cosine of pi over 3 is 1/2. Flip it. 2. That was f of b minus 0 is 0. Minus, that was my mistake from this morning. Secant of 0 is 1 over cosine of 0. Cosine of 0 is 1. 1 over 1 is 1, but that's minus a negative, which is a plus. So I get pi squared over 9 minus 1. Who got there before me?
I did not.
Couple maybe.
I kind of just stopped when you started, and then I was,
paying attention and tracking. So you got there with me. That's good. That's good. That's good. Guys, what was weird when we got to the absolute value we wanted?
The positive.
What do you want to do with these? You're like, I just want to ignore them and say, I'm just going to find the integral the way I know how, and then I'll just throw them in at the end and hope it's good.
Yeah.
No. So, but I know that's what I would want to do, right? If I didn't know how to do it. But I don't want you to get wrong answers. I want you to get right answers. I was bragging on you to period 1 about how much we get done. Guys, don't slow me down today. We got to go. So, why did I split this integral up? The positive stays positive, but the negative area flips. So I need to split this thing up and say, wait. What's going on here is different than what's going to go on here when I have my absolute value bars around my function. So I split it up using a 0, using an x-intercept, and instead of saying, you know what, let's take this one and make him negative, because a negative is a positive. In order to actually figure out who stays the same and who switches, you got to know the graph. Who loves knowing the graph before the problem every time? A couple of you. But how easy is it to find the graph before the problem without a calculator every time? Yeah. So, how do I get you away from your calculator? I say, you know what? Let's just split it up. We'll find each one separately and say, well, you got to be positive at the end. Individually, put it all together, we're done. That's why yesterday we were writing this down, true?
True.
And we were saying, to find the integral from a to b of an absolute value of a function, I say split him up where, what are c's again? The zeros of the function. Good, the x-intercepts. I find the zeros and I split up. For my ones who are like, I think I got it, you got an example, go. For those of you who are like, I was a little behind in writing down notes, write down notes, then try the example, then go. I'm making it so that you don't have to know the graph to know which ones stay the same and which portions of the graph flip. Instead, we're just going to split them up. We're going to say, well, I don't know, I'll just find whatever area you are supposed to have. If you're positive, I'll keep you the same. And if you're negative, I'll flip you. And then you're good. Put them all together. So if you guys know what's going on, be solving that example. Show off. Not only your calculus skills, but your algebra skills and your basic arithmetic skills. Don't mess up the negatives. Can I go yet?
Yeah, you can go whenever you want.
How about now?
No, give us a head start.
Focus. Done? Let me see.
No, I don't know.
I know.
You're not gonna get to see.
Gotta find your zeros.
Oh.
Gotta find your zeros. Anybody find your zeros yet? As soon as you see absolute value bars, you better be like, ooh, zeros. Let's solve for them off to the side. X equals plus or minus 1. Do you split it up with those? Plus and minus.
Wait.
Thank you for being friendly. Good job. Did you split them up correctly? Do you know how or have any questions about how to split them up correctly? I had to find my zeros and I had to split it up with my zeros. Bottom bound to the closest zero to him, that closest zero to the next zero. If there is one, that zero to the top bound. Then I have to good? What am I doing? I found my antiderivative. I gotta do my bounds. I'm leaving the absolute value to the end. Sorry if I mess you up by changing my notation. It can go either way. I'll put little baby brackets. Okay. Then, ugh. Double check my math. Probably almost just as prone to you guys to mistakes as you guys are. That just got lost somewhere in translation. I can make mistakes too. Yay! There we go. Thank you, Nick.
Wow. Oh, dang. Yeah.
Double check. Watch me double check to see if I'm right or not. Can your calculator do absolute value?
Of course.
Yes. Can it do integrals and absolute value?
Of course. Yeah.
Yeah, I can. So I'm going from -1 to 1 of the absolute value of, I'm checking it while you guys are catching up. Was it x squared minus 1?
Yeah.
Ooh, I'm in sequence mode. Hold on, that's not good. Silly Calc BC. Messing with this. X squared minus 1, right? Anybody? No? No one? Alright. Cool.
Yeah, it is.
Wait, it wasn't -1 to 1. It was -3 to 3. I was like, oh, crud. Okay, hold on.
It was extra.
-3 to 3, right? Plus 1 or minus 1? Minus 1.
Whoa.
Go. I'm playing my calculator. 14.666666666666. I think it's good. Math, go to a fraction. 44? It doesn't go to a fraction. What's 44 divided by 3? 14.666666. Booyah! Done. Got it. Cool?
I have a
Questions?
question.
Benji, go.
So why did you have to find the zeros?
I have to find the zeros because I have to separate whatever my bounds are with any zeros that are in between, because at a 0 it could change from above to below and the below flips. So that is my rule. My rule is split up integral using zeros. So I find the zeros. Wherever those zeros are, I split it up. I find my zeros and I split it up.
That only do with absolute values.
Yes, absolute values only. Any huge questions beyond I got lost because you went too fast? Anything besides that? Okay, keep going. Next formula. Where have we seen average before? Last chapter, average rate. How many of you are willing to help me out and say I missed the average velocity problem on the test? Oh, there were a whole lot more of you than that.
Yeah.
Average rate of, I'm going to change the notation a little bit because now our little f is what is inside the integral, who is the derivative of something called the antiderivative. Little f is the rate of big F when you're talking about integrals. Right? And if I want to find the average rate of big F, our forever card would say if you want to find the average rate of something, you take a change in that very something itself, f of b, the antiderivative of, f of b minus capital F of a all over b minus a. So if I want to find, this is all kind of work off to the side to help you get some understanding. If I want to find the average little f, which I call average value of little f. If you want to find the average little f, you're given little f. What it's really saying is the average rate of the antiderivative, which we find with, wait a minute, are we using the little one or the big one in the actual formula itself? Are we using average velocity? Are we using velocity in the average velocity formula? We're using average position or average antiderivative. So, if I'm given the rate formula, if I'm given what I want to find the average of, there's a few different ways of looking at it. One way is to take the accumulation of the area, which is like the integral, and to divide it into pieces based on the distance. And in a sense, you're thinking of like the average rate of change over that interval, but that's the confusing, like, graphical way. The other way to think about it is to find average rate. To find average of something, I have to find a change in the antiderivative. It's just another way of looking at the formula. I'm going to try and do like a motion-y example, even though we're not technically in the motion integration section yet. That's 6-7. Remember the stuff we skipped in our packet? I'm going to try to use motion because it is the most, what am I trying to say? The most concrete example? Oh, that's a really bad way of saying it. The one that you have most daily experience with. It's easier for you to visualize, etc. Guys, if I want, and this is the very mistake that a lot of you made on your test, but hopefully you fixed it in the corrections. If I want to find the average rate of position, that's the same thing as saying the average what? Who's the rate of position? Velocity. So they could ask for, AP guys love to confuse, right? That's why they're the AP guys. If they say find the average velocity, you have to read into that and say, ooh, they want the average rate of position. So if I have position, I just do x of b minus x of, do you see a v in this solving anywhere? No. I'm not taking derivatives. I'm not doing instantaneous. I'm trying to find the change in the displacement over the change in position over change in time. The way that you guys always learned how to find the average rate. Oh, it's so cute. That's all you could do. Back in pre-cal, algebra 2, algebra 1, physical science, wherever you did it. Oh, by the way, this is forever. Number
36.
Thank you. You guys back her up?
Yeah.
Okay. So I would plug in and I would solve and I would get a number, and if someone could get that for me, it'd be my hero, and I would have, yay, average velocity. But what if, instead of being given, what if I hid this whole thing, and what if I said instead you were given the velocity function, and they ask you to find the average value of velocity? Wait, that's the same thing as find the average velocity. Is the question,
-7.
what is it?
-7.
Anybody back her up?
Yeah.
Your calculator's not even out. Benji, how can you back her up?
It's in here.
Right.
See?
If someone's just chilling, can you check it and make sure it's right? So if I hide that, what if this was your problem? Question. To find average velocity, am I looking at velocity? No.
No.
I need to accumulate changes in divided by changes in position over changes in time, and then figure out what the average velocity is. How do I go backwards from velocity? How do I get my x of 5 minus x of 0 all over 5 minus 0 if I don't have x, but I have its derivative? F of b minus f of a. Antiderivative of b minus antiderivative a is the exact same thing as the integral. I'm using the same formula. I'm just looking at it a different way. Has anybody backed up -7 yet?
Yeah.
Is it good?
Yes.
Okay. Guys, I'm going to zoom out. Why on earth would I show you, like, whatever, you gave me position? Why are you making it all confusing? It's because the AP guys could just give you velocity and say go. And they could give you one that you couldn't anti-derive at all in your head, and it's a calculator problem, and you have to know what to do. To find changes in position over change in time, if you have position, just plug it in. And this is average velocity, average rate of change of position. But if I don't have position, I can get to position if I have the rate formula by going backwards, by integrating. If I have the derivative, change in antiderivative is just integrating. It's a little bit confusing, but guys, it'll be the exact same thing as -7. A few of you guys might have questions like, but without a point, how do you know what C is? So how do you know what to subtract? Well, the same way that C's cancel when you subtract, the -1s cancel when I plug in. Anyway, a few of you might have that question, most of you wouldn't. Average value of, what am I saying? When you're given what you want the average of, you gotta go back. So for some of you, if this was confusing, you'll have the same issue here. You've gotta just get your mind around it. I can explain it in more depth, but not right now. Are we ready? FTC Part 2. We are at like the application, like the tail end of this section, guys. You got the big fundamental theorem of calculus, but what are some practical outworkings of this? I'm going to change a couple things real quick as I zoom in on what you're supposed to be writing for forever number 37. Anybody?
Yeah.
Thanks.
Plus you.
Wait, no. Hold on. No. Shh. Remember, you can't make up stuff. Not in calculus.
Oh, no, I was saying like 30 plus you.
Oh. 30 plus. Clever. Okay. As you guys are writing, there is an if, there is a condition that has to be met if f is continuous. But if f is continuous, if you see derivative of integral, what should your mind already be like? Wait a minute. Integral is going back, derivative is going forward. So if you go back and forth,
It's the same.
it's the same. That makes sense, right? When does it get tricky? When you're not going from a number to x, and some of you just the number to x part gets confusing. We'll talk about that in just a second. I have an illustration below that's kind of an example, kind of not. What time do we get out? My phone's recording. So, coming back. If I want to find, I have defined capital F as we have seen him many times now to be the antiderivative, right? He is the function whose derivative is the integrand. And I'm going from A to B of, give me a number, any number, I don't care.
52.
52 to x. Okay, the next one I'll do 17. 17 to x squared. Okay. Wait! Your first question should be, I can't do this. You didn't give me a function. How can you take the antiderivative, Jezreel and Catherine, if I don't have the function itself, right? How do I find the antiderivative? I note him and say, hey, whoever he is, I would plug in the top and I would plug in the bottom. Seriously? Yes, that's all you can do. And then you say, but I need to take the derivative of what the integral equals, right? Wait, what allows me to go from this to this? The fundamental theorem. FTC. The integral from a to b of a function is its antiderivative of b minus its antiderivative of a. Shh, focus. I should listen to this video and count how many, never mind. I'd be depressed. If I take the derivative of, isn't that f prime of x? If I take the, wait, if I'm plugging a number into a function, what am I getting out? A number. What's the derivative of any number? Gone. Who is f prime? Look, that's why. Wait, but what if it was 17 to x, or 0 to x, or negative 100 to x, or 1 million to x? I don't care. His answer, when you take the derivative, is f of x. What changes then with this whole u prime thing at the bottom? Hold on, pause. Antiderivative. I don't know who he is. I don't even know the function. Cool. Put capital F. Minus f of 17. That's FTC, right? I'm taking the derivative of that integral. The derivative of f prime of x squared times u prime minus the derivative of, wait, plug in a number, you get out a number. Derivative of a number is?
0. It's gone.
So what's it going to be? F of x squared times 2x. Here is where my f of u times u prime comes in. I'm giving you this so that you don't have to do this every time. FTC part 2. It's a natural outworking of FTC. Shh. I plug in antiderivative of b minus antiderivative of a. I take the derivative. I get back to the original unless I have a, I'm not done yet, u, then you have a u prime. Pause. Last one. MVT for integrals. MVT for integrals.
Pause.
I will write it up. I will put it online. Here's the dealio, guys. This is a weekend, so what do you have to do?
WCC.
WCC. You also have homework number 33, but pause. Could there be some MVT ones that get a little confusing? When you see MVT in directions, I will take 75% and take those off, and that's what I will be spot checking on Monday. Bye. See you later. Alligators. After a while.
Are you going to the game tomorrow? Huh? Are you going to the game tomorrow?
Yes. And today? What? Bye, guys.
Be there.
When you have yours. You're almost done, guys. 2 more. Dos más.
So I forgot.
Classes.
No, we just have. Oh.
6 and 7?
That's why I was like trying to figure out. I was like, wait, so the next class is going to go till 12? Because I don't count me as a class.
Alright, so you guys want me to do that? Alright.
Have a good weekend, let's do it.
Thanks. You too, Nick.